Ron leaves a parking lot and follows a trail due east for 6 miles to a lookout. He then turns and walks on a bearing of north 50 degrees east, but finds he neglected to have his pedometer on for that leg of the hike. He reaches a trail that heads south 72 degrees west that goes back to the parking lot. All right, let's draw a picture what we've got going on. So we're here at the parking lot, and he walks due east for 6 miles. And then he heads on a bearing that is north 50 degrees east. So the way bearings work, we measure off from a line that is due north then, and we swing around to the east by 50 degrees. So this angle right here is 50 degrees. Then he finds that he didn't have his pedometer on for that hike, so we don't know how far that is. Maybe we'll call that X. He then reaches a trail that heads south 72 degrees west. So from this point we measure off south and we swing around to the west by 72 degrees, and that trail goes back to the parking lot. So this whole angle right here is 72 degrees. So we want to know how far he is from the parking lot, so we'll call that Y, and how far he walked from the lookout point to the parking lot. So this was the lookout point right here, so that was the X. All right, so we see we've formed a triangle, and I've got one side of the triangle 6. I don't have any angles in the triangle, but I can get two of the angles. I know this is a 90 degree because we were headed due east and then we measure off from due north, so that's got to be a 90. So that whole angle in that triangle would be 90 plus 50, or 140 degrees. Now looking at the top angle of the triangle, the whole angle to south is 72, but the angle in the triangle doesn't include all of that. But I see I had the 50 degree angle. I'm going to draw a picture of this piece of it right here. So this was 50 degrees, and so this angle right here needs to also be 50 degrees because they're parallel lines, and that's alternate interior angles. So that means this little piece of the 72 degree angle is 50 degrees, which if we subtract then leaves us the rest of the angle that's in the triangle, and that would then leave us 22 degrees, the 72 minus the 50. So I have a triangle, and I have angle, angle, and side. I have a side of 6. I have the angle of 140 and the angle of 22. So I can use the law of sines now to find what I'd like. Let's go ahead and find Y first, how far it is back to the parking lot. So setting up the law of sines. I have Y over the sine, the angle opposite Y is 140 degrees, and that's going to equal the side I know of 6 over the sine of the angle opposite 6, and that's the 22 degrees. So now I can multiply the sine 140 over here, and then I can get the calculator, make sure I'm in degrees, and I can hit 6 sine of 140, finish the angle, divided by sine 22, and that will tell me how far it is back to the parking lot, and we'll go to 1 decimal place. So it looks like that's 10.3, so 10.3 miles back to the parking. Maybe I'll put it right on here. Okay, how far did he walk from the lookout to the spot where he was there? So that's X right along here. And so let's go ahead and set up another law of sines. So we have X over the sine of the angle opposite at X. Well, that's this angle here in the triangle, and I don't have that, but I do have the other two angles. So I can take 180 degrees minus the 140 degrees minus the 22 degrees, and that gives me 18 degrees. So sine of 18 equals, and then we'll go ahead and use this again, which is 6 over sine of 22 degrees. So we can multiply the sine 18 over here, And then grab our calculator again, and we will do 6 times the sine of 18, and that's going to be divided by the sine of 22, and that gives us how far he walked there to 1 decimal place. That's going to be 4.9 miles.